Hey guys, today we're going to write recursive functions using TDD. Now most people find recursive functions quite difficult, but actually they're pretty straightforward. All you really need to do is to make sure that you stop and you call itself. And the way you do that is you build it up from the simplest case, i.e. start with the ability to stop if you like. I'm going to write it using TDD as if you mean it. That means we're going to be writing what might look like strange code to start with, but we'll refactor to make it cleaner as time goes on. And basically you can see my normal development environment here. I usually put my test class on the left or right, and my code class, if you like, on the other side, just so I can flip between the two quite quickly. Also, I'm using Visual Studio 2015 Community Edition, ReSharper 10 and NUnit for the test framework. Obviously I've linked the two, as you can see on the right hand side here, I've linked the test project, click the wrong one, to the main projects. At the moment it's not linked in. So to do that, we'll may as well get started. So as always, add your reference, find your other project, and then you're in. Now the first test is pretty straightforward. With recursive functions, it's the base case, if you like. And now we're going to pretend to code up, if you like, the factorial function. Now for those of you that know what factorial is, that it's say you have number 3, you multiply it by one number less than it, and one number less than that, etc., until you get down to 0 effectively. And the simplest case is 0 factorial equals 1. Yep. Right, pretty straightforward. So on the left hand side, we just write our test. Oops. On there, dot factorial of 0. And of course we set that as our value, or result. That's a better word. And then we say our usual assert result 2 and then 1. Right, so that should basically be our test. And we just create our little method, which throws it on the right hand side. And stuff. Those thrown in a very strange integer here, or value. There we go. Right. So we build that. Run that, and it's failed. Perfect. So it's not implemented. So now we just have to implement it. Now, obviously, we are using TDD as if you mean it. That means we will return. Oops. 1. Now I know it looks really weird, but that's what you do when you're TDDing as if you mean it. You literally do develop the simplest case and then refactor this result into the proper way of working, which will come along on the second test, if you like, not the first. So to prove that, gone green. Perfect. Now we do the second test. Now the second test is pretty similar to the first, except this time we're just going to put another number in. Test, in this case 3 factorial equals 3 times 2, which is 6, times 1, 6. So we're basically looking to get 6. Okay, as before, we take our little result, factorial, sorry, get ahead of myself there. Assert dot that result 2 and 6. Straightforward. Now this obviously will fail. Right. Now to solve this, obviously we have to refactor it, but we can't lose that first case. That's the key point. You can't lose that first case. So what we need to do is make sure that we turn this into a variable, say. Yeah, that's good with us for now. Yeah. And of course, as we can run that if we wanted to. That bit stays green. This previous one's still red. Yeah. And in this particular case, you have to remember that the way this turned out, that case was the 0 case, if you like. So factorial of 0, which we've got here, right? We have to maintain that case. So if in this case, if I equals 0, and return, still looks odd, I know. It looks very odd. Still going to be green and red, perfect. Now what we have to do is understand the next case, which we know is 3 times by the previous correct case, which if you know your mathematical induction or know your recursion really well, you'll know it's exactly the same structure, just one less item in it, in this case, for the factorials. So we will say I times by factorial, excuse me, I minus 1. Okay, now hopefully, if I've covered this right, you get 2 greens. Perfect. Now, at this point you can of course check it in, but it's really messy. So what we need to do is remove what we're not going to use. Right, so of course that involves getting rid of this guy. Yep. But also looking to remove this slot, because this is literally immaterial as well. Because of course the first return will return, second return will only be hit if that if statement isn't true. So again, right, there we go, dead easy. Now we can go one better. Start to inline this guy. Oopsie. Okay, so fully green, perfect. Now, so we started with the massive code, and we've simplified it quite a lot. Concepts here, specifically TDD as if you mean it. That means you literally do return exactly what the test says, nothing more, nothing less. And then you refactor the second time to make sure it passes. The second thing we've shown is how you test recursive functions, which, if you're familiar with mathematics, and especially pure mathematics, the concept of proof by induction should be quite familiar here. Because what you've done is you've tested the base case, assumed the previous case to where you are is true, assumed k, assumed in this case I, is true, and then proven, that's what your test is doing. This test is proving your case is true based upon the results of the previous case, if you like, on that assumption. And that's proof by induction. And that works with quite a lot of stuff, especially anything with a recursive element to it. We've also shown how to refactor. And I hope you won't be as fearful of recursive functions now that you know how to TDD it. And this same principle works with trees, lists, or any other scenario where you'll have a series of recursive elements to it, any fractal structures, if you like. I hope you guys found this useful. If you have any questions or comments, please put them in the comment section below. If you have any suggestions, also drop them in. If you did find this useful and you think others would find it useful, please feel free to share it. And I hope I'll catch you next time.